So the idea of the decoder is to determine what the input is coming in from the 16 switches that represent the frets. So in this file, we are looking at a case X statement, which is a variation on a regular case statement, but the difference is it includes don't cares, so that when multiple switches are flipped, the system will only recognize the higher of the switches that is up, thus preventing some sort of impossible combination of frequencies to be played at the same time. For example, if you had the first fret and the third fret pressed down for first and the third switches flipped up, it would only play the third frequency.
Okay, so then we're going to go to the code for the tuner. Every guitar actually has to play music, so this is pretty important. How we kind of coded the tuner is just blocks of case statements for each string. So we're just looking at the first case statement, case E or string E. It takes in the frets that we just found in the decoder. It finds which one is switched on, and then it assigns the value of that frequency, or it assigns a value, and that value is the frequency of the clock divided by the frequency of the actual notes. So for the first line, that's what, E2, that's the actual note that's being played. And so then we repeat this process for all four of the strings. And then at the end, we have just kind of always blocks for actual tone generation. So it's a counter out that gets to the actual tone, frequency of the tone being played. And then at the end, it will then, and we have all these blocks for each string as well. And then at the end, it's an assigned statement to speaker, and we're adding up all the different tones from each strings.
There you go. Now we go into displaying our guitar to the VGA. So at the top here, we just have some frameworks for creating the VGA, having the X and Y coordinates, setting our synchronization signal, etc. Then we come down to this large block here from line 41 to 59. Here we are creating all the frets on our fretboard. So each one it's a very simple framework behind the scenes. All it does is it takes in the beginning X coordinate and the beginning Y coordinate and creates a 4 pixel wide by 150 pixel tall bar. And then it will output the basically a Boolean value depending on the current X and Y position in the VGA on whether to display a pixel in that area. And that is in the disp val out, and that is for all of those wires right there. If you keep scrolling down, we now have, right there. We now have the highlighting fret, and this is the one that turns green to indicate which fret we are on. And for that, we have to have a case statement that basically says, depending on the active switch we are considering, this is going to be the X offset for this fret. So we can see that the Y offset is set for it. However, depending on, like, let's say it's the 5th switch, then it'll be offset by like 200 pixels, and it'll coincide with that fret and make it green. If we keep going down, we now have the VGA strings right there at the bottom. And what these are, can you scroll down a bit more, please? And what these will do is they have the same general parameters as the frets. They have a X, Y, and a Y offset because they will span the entire screen, so they don't need an X offset. They take in the active X and Y coordinates from the VGA, as well as a reset signal, clock signal. And then they take in a signal called vibrate, and that indicates whether that string is quote unquote being played. And if it is, that value will be high because it's corresponding to the same button. And then inside of the VGA string module, it will basically just oscillate the Y value up and down by 2 pixels. And then again, the last parameter here just outputs a Boolean value to the wire representing that string on whether or not the pixel should display a value. Finally, we come to the end where we combine all of these together. So first of all, we just bundle up all the frets into one wire. It's the same thing for the strings, just bundle them all up. And then we do a little bit of funky logic with assigning it to the R, G, and B. We will say that we only display red and blue for the frets that are not the active fret, and as well as for all the strings. And for the green, because we want to highlight in green, we'll say highlight for all frets, all strings. And then we added a little bit extra color for the active fret. So the green channel is extra high for the active fret.
And finally, in the guitar.v file here, this really just combines everything that we've talked about in the decoder, tuner, VGA control. So this really incorporates the FPGA functionality with the switches and the buttons, also accounting for the audio output and the VGA display output. And so we just really have to push all of these values through the decoder right here, through a clock cycle with the frets and with the tuner and the VGA control. And simply that guitar, combining all these files together in the guitar, we'll be able to display it on the VGA.
Go. All right, so this is going to be the E string open. There's going to be the first fret. All right, and the second fret. The third. Fourth. The fifth. Sixth, the seventh, the eighth, the ninth. How about the 10th? Getting higher now, the 11th, the 12th, 13th.
I mean, what it should be is just
14th, 15th. Ready for something super high? The 16th. Oh yeah. All right, let's go to the next string now, which is the A string.
I think he can.
Yeah. This is the open string, no switches up. All right, we're gonna go up again. So the first, second, third, fourth.
Well, no, like after,
Yeah.
like you make it if statement and then the action.
Sixth.
Fit all the actions in one line. You can.
Seventh,
But it's just
eighth, oops, 9, 10, 11,
You got time?
12, 13,
yeah, stop.
14. Now the last one for the string. All right, so now are you ready for the D string? All right, this is gonna be open. Oh, wrong one, my bad. It's this one, slightly lower now. All right, now we're gonna go with the first one, first fret, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, 13th, 14th, 15th, 16th. All right, now we're on to the last string, which is the lowest string, which is the G. Oops, wrong one again, sorry. All right, we're gonna go up again. First, second, third, fourth, fifth, sixth, 11th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, the last one. All right. And then something else to note. So if you were to have two switches flipped, say you have this first one and I don't know, this fourth one, right? So when you play the note, it's going to only light up on the lowest switch that is up. So it'll play the lower or the higher note. So you see that they're two up, and then if I lower that one, then it goes to the fourth one, and then it plays the fourth note. And if I do something higher than that, it'll stay on that lower note, or that higher note technically. So that's an interesting feature that we have implemented here.
Yeah, and to recap, as you can see, each of these 4 buttons here correspond to a different string on the guitar. The left button is used for a reset. So if we just imagine if someone's at a concert and they smashed the guitar, and we got a new one, we'll hit that reset button. Broken pieces are cleaned up, and aha, new guitar. None of the functionality changes, and like Amar was showing in the video, for each switch corresponds to a different fret. We got 16 frets. I'll just keep going up and up and up. And one last thing to note is also the fact that guitars usually have 6 strings, but you can see on the VGA display that we only have 4 strings. This is just due to the limitations of the FPGA with the buttons here, where we can maximally only have about 4 strings represented if we wanted to include a reset button. So maybe if we were actually to create a full VGA guitar, maybe we could have a VGA that has more button inputs to represent each string. But otherwise, this is our video demo. Hope you enjoyed, and let's make some music.